bit earlier. All right. Let me share again. Okay. Now, that's fine. We missed all that. That's fine. Nothing was there that was useful. So this NP hat, NQ hat check, if it's greater than something, what does it have to be greater than in order for this to be normal enough? What do NP hat and NQ hat have to be at least? Anybody? So we have, for means, we have n greater than 30. For percentages, the check is not n greater than 30. It has to involve the percentages somehow. So I know we talked about this, and I know it's been a little while, but does anyone remember? Nobody. Okay, so let me get you off the share. Let's talk about this again. Let me see. Stop share. Bam. Okay. Let me see. Pin this. Yeah. Too little, too late there. All right. So remember, the whole idea was to get away from that wall. NP has to be at least 5, so that the highest bar is more in the middle, right? Let me mirror my screen real quick because it looks freaky to me. There we go. So it has to be 5 so that it has room to grow and then room to shrink. And then NQ controls that side. So it just has to, the highest bar has to be in the middle somewhere so it has room to go up and come back down. That's the real quick rundown of what we talked about last time. So this check here takes the place of n greater than 30. So as long as those two things are true, then you're dealing with a distribution that is normal enough. So coming back to this. Pow! Okay. Love you guys. I think we did this part last time, and of course, let me see. Where's my control? There we go. Let me blow this up. Bam! All right. So P hat was 459 divided by 652. So if you do that, 459 divided by 652. Everybody's got this. Thank you, Quincy. 0.704, I like it. So that's 0.704. So no matter what clothing they're wearing, P and Q have to add to be 1. So what would Q hat have to be? 296. Kick ass, right? 1 minus 0.704 is 0.296. I also said last time that the percentages have to be at least 3 decimal places, the P hat and the Q hat. So you can go more. You can make it 4 so it matches up with just about everything else if you want to. I don't care. It's got to be at least 3. What's N in this case? I think I made a semi-big deal out of this. What's N? Yeah, Quincy's got the load today. 652. She's carrying all you guys. All right. Right, she? Shit. Sorry, Quincy. Now, if you do, I can't remember if I told you the shortcut for this, but if you do N times P, 652 times 0.704, and again, what we're doing right now is in place of N greater than 30. I think at this point, the N greater than 30 thing is ingrained in your brain. What's more important than just knowing N greater than 30 is knowing what it means. It means that it's normal enough. So N greater than 30 is one test we have for means. This is a percentage problem. So instead of N greater than 30, we do this check. NP and NQ greater than or equal to 5. So not surprised. If you do this, you will get 459 just about if you round it. And that's not surprising. I think I talked about that last time, right? Of course, look over here. where my cursor is. Hey, cursor. N times P will, of course, be the number of successes, 459, because that's how we made P hat. So this, if I check NQ, so this is bigger than, get in there, bigger than or equal to 5, check. And then if I do NQ hat, come on, buddy, 652 times 0.296, I'm gonna get, you can do it, Jeff, 193? Is that right? I don't know, I'm gonna pretend like that's right. 640, 652, yes. Thank you. And that is greater than or equal to 5. How did I do that so quickly? I just did 652 minus 459. That would be the rest. All right, so that whole thing we just did replaces the n greater than 30 requirement. N greater than 30 requirement is for problems dealing with the mean. This is for problems dealing with percentages. Bum, bum, bum. Okay, so that means that we have a thing that's normal enough, so then we could do this problem. I want to be 96% confident. I don't think I got to this point last time. Can you take a minute? Don't write anything down. Figure out what the z-score is for that. I'm going to draw the picture over here. Bum, 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 bum. That's beautiful, Jeff. Oh, shakes. Get in there. I hate lag. You can do it. Oh, so much lag. There we go. Just make you red too. Bam. All right, so right now, just in case you aren't really paying attention too much or are not quite awake, I want you finding the z-scores for this situation. Do not write them down yet. Don't tell anybody else yet. That'd be awesome if I could like delete stuff. I guess I can't. Oh. All right. Somebody have the answer yet? Well, shit. If you're really paying attention, I left the answer up there, but because I'm just on the ball, right? Look here. So you should have gotten 2.05, right? Yeah, okay. Then Tana, 0.04, that's outside. Livia, 0.02, that's on, which way would it look for you guys? I don't know, that side, whatever the hell. So right here, get in there, come here. This, right there, come on, we can do this. All right, 0.02 is right there. You guys, everybody, anybody not understand that part? Okay. So then if you look up, and I know it's a negative z-score because that's freaking below the mean. If you look up on the negative side and you try to find, don't look at 0.02 as a z-score. No, it's a freaking area. It's going to be in here. And if you find it, someday we'll find it. You can do it, Jeff. Oh, I'm tired. Let's see. Here it is. 0.0202. Screw it. I'm not going to try to find that. 0.0202 is the closest I can get to that, and that would be negative 2.05. Get in there. All right. There we go. All right. Anybody not with me? Either mentally, if you're not physically with me, that's a problem. You've gone back to bed. You're like, my name is up there, Jeff. I'm here. Okay. So finish problem out. Make the confidence interval. You got everything you need for this formula. Do it. You have everything you need for this formula right there. So do it. Someday we'll find it. Yummy. Just to remind you guys, the plus or minus for the two z-scores on that picture are in the formula. Those kind of things are so kind of beautiful. You can see in the formula what you can see visually. It's really kind of nice. Could be just me, I don't know. Times the square root of 0.704 times 0.296 divided by 652. All right, that's how it looks on my crappy screen. Sorry, I'm not going to try to write on this because then you couldn't read anything. So first thing you should do is to calculate what the error is, the give or take, how much we think we're off by. So if you plug in this part of the equation, 2.05 times the square root of blah, 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 see what you get. That's how much we think we're off by. Someday we'll find it. Why am I so musical this morning? I don't know. Or you know, trying to be, I guess. Anybody get that part of it yet? This is so weird. All right, I want it to be like. Nobody? Has anybody gotten the error yet? Yes. This is one time when the error is a part of the problem. So normally your error is a mistake, but this is beautiful. So this is how I got it, and probably this is how Monica got it. All right, 2.05 times the square root of all that business. So 0.0366. 0366, yeah. So let's come back to here, 0.0366. And now you subtract that from 0.704 and you add that to 0.704, right? I can only stand half what you're saying because of skipping. I'm sorry, Maddie. It's got to be your Wi-Fi, because is anybody else experiencing Wi-Fi issues with my video? Okay. No, okay. I'm really sorry, Maddie. I think the results are in. It's your Wi-Fi. I'm sorry. Do what you can. Here's what I get when I do those two things. You guys see that? 0.667 to 0.741 if I round it. 0.667 to what did I say? 741. Let me pull this up here. Boop, boop, boop. All right. Anybody not with me at the moment? You lost me at, oh shit, I'm not recording. No. All right, looks like everybody's with me, at least that's actually with me. So try to write the conclusion. Remember, your units are going to be percentage. So convert those decimals to percentages when you write your conclusion. We are farmers. Oh, let me see. Let me try to delete some of this stuff for later. Bum, ba-dum, bum, 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 bum. Come on. Bum, ba-dum, bum, 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 bum. Go away. Stop. Disappear now. What do I have to do to make you disappear? Okay. Okay, holy macaronis. All right, so let's see. I'm gonna write down what I get here. We are 96% confident. Where's percent, Jeff? There you go, buddy. That the bing, interval 66.7% to 74.1% contains or captures bing. And here's where I like to say, this is the plagiarize step. Who gives a shit? Just copy down, find that 96% for the true proportion of people that voted. So we are 96% confident that the interval blah, blah, blah contains the true percentage of people that voted. That voted? Sure, Jeff. I'm too lazy to make a whole other line. Do you guys understand that? In general, plagiarism bad. When you're writing the conclusion, you want to talk about what it is you're supposed to answer so you can just copy that right down from the question. It's crazy. Okay, maybe. So you have to put it, we are this confident that the interval I made catches the true thing. You can't write that some other way. And I think I've gone over that at least once about why that's true. Okay, any questions on that problem there? Because I'm going to take us off share because I got to talk about the idea behind the next. Well, we already did the work, to be honest, for this next problem. We already talked about the N formula for the sample means. This problem, sorry, I don't mean to make you sick. Remember this problem here, part C? How many dolphins to be within 0.5 inches? So we had to solve the error for N. So here in this equation right here, the error is this piece. Got it, the Z square root blah, blah, blah. So if I say error equals that piece, I can solve for N. I'm not going to do it again. We already basically did the algebra for the last N equation. Let me stop here for a minute. Any questions about anything I just said? Okay. Can everybody who hears me right now hit the yes button? All right, let's see. I got a couple things. If you click participants at the bottom of the screen, you will see the yes and the no buttons. So it looks like some people don't see them. They're trying to chat it at me. All right, so Maddie, I know you're there. Richard, I don't know if you're there. Vanna, you wrote to me. All right, I'm calling you out, Richard. You out there? Give me something, buddy. Oh, shit. I don't know. And Johanna, are you out there? Yes, you are. Okay. All right. It's just Richard I'm worried about. I called him out in front of everybody. I'm a jackass and I don't seem to care. Okay. Coming back over here. So I have this formula here. It's exactly like what we did up here. It's exactly the same question. How many what's to be within what? And the question, Maddie, E, what does E stand for? Anybody? What does the E stand for? Eek! No, what does E stand for? Error, yeah. No question mark, error. It just does. That is the part of the formula that is the error. And if we identify it as E, we're able to solve for N. So so you got two parts to this. You got these crazy ass formulas with these stupid letters with these hats on them. And you're like, what the shit? Math is so weird. But what's at the bottom of this thing? What's it trying to get? All right, I want to be within this much. I want to be really close. How big of a sample do I need to take to make my error that small? Because we've known since day one that the bigger the sample is, the less error, the less variability, the less error that I will see. All right, so in this problem, I've already identified for you what the error is, and it's that magic word. It's going to be used 95% of the time. Within, that's the magic kind of general word to identify the error. How close do you want to be? They could say something stupid like, we want to be off by at most 3%. Okay, that's the error. That's how much they want to be off by. Now, the really tricky part about this particular problem is, what do I not know that the formula needs to know? All right, I don't know the z-score, right? But I can get that from the 99% confidence thing. Do you guys remember the baby chart? Baby chart. I'm sorry. Any parents out there? Just got that stuck in your head. I'm really sorry. The baby shark thing. Oh my God. So 99% confidence is 2.575. So shit, yeah, if I can, I'm going to use that chart, that little baby chart. Mama chart. Sorry. Z equals, what it is, 2.575. No, Jeff. Blah, 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 blah. Okay. How are we all doing out there? So from a practical standpoint, the question says, how many somethings would we need to get? Okay, that's going to be a formula solved for n. And we're only going to have, 3 of those maybe. 2 of them are almost going to be the same thing. Yeah. So you need a formula solved for n because that's what the question is asking for. This is about percentages, so you need the one that's got percentages in it. So it's going to be the z squared p hat q hat over e squared. I know what e is. I know e is 0.03. I know what z is, but what the hell? What the hell? What the hell are p hat and q hat? That was not COVID. What is p hat and q hat? What's the best guess? If I said, 50%. If I said, what percentage of the people at the Sprouts down the street right now are women, your best guess is 50%. Now, that's not always your best guess. So it's sort of a bad example. But what this does, I really want you guys to all be with me because this all makes so much beautiful sense. If there is something we don't know about a problem, should our n have to be bigger or smaller to cover for that? If there is something we're not sure about in a problem, yes, it's kind of like we're penalizing ourselves for not knowing something. So in this case, we don't know what p hat and q hat are. We got to guess for them. And 0.5 is the one that mathematically makes n the biggest it could be. So we have to guess that, get in there. You can do it, there we go. P hat and q hat, P8, 11, and q hat are 50-50. So go ahead and plug that in the formula here. Now we got everything we need. I'm sorry, not that formula, this one. We know what z is, we know what p hat and q hat are. We're assuming them to be 50%. We know what e is, 0.03. Plug the old formula and see what you get. Don't tell me anything yet. Let me see if I can sneak down here and erase some of this stuff. It's from my other class. Don't pay attention to what I am doing. It doesn't matter. Bam. All right. Jeff would just learn to prepare. That would be amazing. So let's see. What do you guys get? Let me catch up to you. N equals z squared. So 2.575 squared times 0.5 times 0.5 divided by 0.03 square. I like it. So one big mistake people make is they forget to change 3% into 0.03. And then you get weird ass ends like you need 0.7 people. That doesn't make any sense. So don't circle that shit and turn it in. Anybody get that yet? Let me catch up to you guys. Ooh, yes, that sounds familiar. 1841.84. Now, what's wrong with that? I think I said this. Let's talk about Dolphin Dexter yesterday, the other day. I don't want you to have to go out and chop people up. Yes, so you have to round it up to 1842. Is that when Columbus sailed the ocean blue? In 1492, Jeff. So just off by 400 years. Whatever, Jeff. That's the problem with rhymes. You don't forget the idea, you just remember the rhyme. Okay. So I would need 1,842 people to make sure that I will be within 3% of the real percentage who will pass statistics the first time. Part B, the only difference between A and B, in Part B, I have an estimate of what P hat is. Have you guys ever heard of a preliminary study? Preliminary study. So what they do is they do a small scale study. They ask questions and they get percentages so that they don't have to assume it's 50-50. They can use their what they find. So in this case, we talked to 42 stats students and we found 31 of them passed the first time. So what do we know P hat is? What's P hat then? Yeah, not PHF. There you go. In fact, what does P hat mean in general? P hat is the percentage from a sample. Just like X has a bar on it means the sample mean, P with a hat on it means the sample percentage. So we found 31 out of 42. That's exactly what we do. 31 divided by 42. And what do you guys get? Let's see if I can beat you. I beat you. Ha, ha, ha. I don't feel very good about that, actually. There we go. All right, make sure you can get that. So then what's Q hat going to be? Let me move this over. Today, computer, go at a decent speed. Come with me. Come with me. Ah! Get over there. Okay. The joys. Okay. Q hat will then be what? God, I really want to write Q hate. That's just so weird. Yeah, 0.262. So now we do the exact same formula we just did up here. We just we don't guess 50-50 because now we know this is true. Let's see how much fewer people we're going to need now since we did that preliminary study. N equals 2.575 squared times 0.738 times 0.262 divided by, where'd you go? 0.03 squared. Oh. So the only difference between part A and part B is instead of 50-50, because we didn't know in part A, we use what we know in part B. And I promise you the N will always be smaller. What does that come out to be? Ooh. Oh. Now we're closer to Columbus. Sorry, 1425. Did you get 1424 point something? Is that what it was? You could just do it, Jeff. No, I don't feel like it. What do you guys get? 1424 point blah, blah, blah. It doesn't matter. 1424.03. You would round it up to be 1425. That still seems like a lot, but isn't that over 400 less people that you'd have to talk to? So that is the power of a preliminary study. Get some idea of what the answer is, and then you can have a better feel on how many people to be within so much. Okay. Any questions on that? That is section 8.3. And yes, we haven't done section 8.2 yet. We're about to do that right now. I'm so excited. So if you, okay, so not seeing any questions about this. Let me get back here, close up. Where are you? Oh, crap. Get out of the way. Okay. There it is. If you logged in after I said this, I have posted to Canvas this sheet, and it looks really exciting. It looks really a lot of fun. So go to Canvas if you can right now. And if you look in the pages part, let me try to get there. Where am I at? Here we go. If you look in the pages, you'll see a few nifty things. And right here is the T-scores. That's what I'm looking at. T-scores. Okay, so I'm going to stop sharing so we can talk about the idea. Okay, let me see. Bump, bump, bump. Good. All right. Oh, let's see. Oh, I got, look at this. Look at that. Jeff has stepped up in the world. Damn. That would have been funny if it didn't work worse shit. Sorry. All right. So here's the idea. We know this formula right now. Right? And there's something that's a little unnatural about this, but it actually does happen where we don't know the population mean, but we do know the population standard deviation. It's not, all right. So for example, I can know the population standard deviation of women's heights, let's say. And then I go to a small town in Missouri where the women are taller than average. So I could find a confidence interval for the real mean height of women in that town. I already know the standard deviation of all women. That's the same for them too. They are a part of that group. But I'm trying to find out the mean height of women in that area. So that is how I could know this, but I don't know the mean because I'm talking about a mean for a smaller subset of the population. All right. Okay. Now, what has to happen? Let's say I make that interval and I get what Jeff? I don't know. What do you got, buddy? 59 to 65 inches. Right? I forget the average height of women now. Oh well, too bad, Jeff. That sounds kind of low. Anyway, all right, just do. Would that interval get bigger or smaller if I did not know the actual population standard deviation? If I only knew the sample one? So what happens if there is something about the problem I don't know? Is that, do I get rewarded for that or do I get penalized? Yes, Monica. If there is something I don't know about the situation, I have to penalize myself. I don't mean you have to beat yourself over the back with some kind of birch tree branch or something. But so somehow this would have to get larger. I can't change this. I'm going to see that. I am going to replace, let's start to create this. That is going to be set. I'm going to get that from a sample. I can't change that. There's got to be something I change in the formula to make my interval bigger to cover for the fact that I don't know the real standard deviation. I can't change that, right? I can't, that's going to be S. That's true. I can't change N. N is going to just be the sample size. So the only thing I could really change is this. Now here's something interesting. The guy who created this T distribution, that's what we're going to use. In fact, real quick, T-scores are always bigger than what the Z-score would have been. That makes the error larger. And I like to say it covers your ass for the thing you don't know. Okay, maybe. So we just have to make a larger thing to cover our ass because there's a part of the problem we don't know. We're trying to estimate it with S. The guy who created the T-scores worked for a company called Guinness. Anybody know Guinness? It's what got a lot of us through physics. The Guinness Brewery, they did not let people publish their findings. They kind of took ownership of the findings of any of their employees. So this guy did a lot of work to create this distribution. He didn't want Guinness to take credit, so he published it under a pseudonym. He published it anonymously, but he called himself Student. So you'll see this thing referred to as Student's T distribution. And it's really this guy, which of course I forgot to look his name up again. I think it's, God, it just had it. Not William Lancet. What the hell is his name? Shit. Oh well. So we're going to take, the only hard part about this will be making sure you see how to read the chart. Otherwise, I really want you guys to notice, where do we get this? From a chart. We put it in, we do it. Where do we get this? From a chart. You put it in and you do it. I mean, so it's not going to fundamentally affect how much work we have to do. It's just going to be a different chart to look at. Maybe. All right. So one key thing on this chart that we need to talk about is what the hell does degrees of freedom, or as I affectionately call it, degrees of freedom. You can take away my dignity. Sorry. A little Braveheart reference. Degrees of freedom. Okay, here we go. You ready? So this is a side note, a big time side note, but this is on the chart. I want you to understand this. So here we go. This is a whole side discussion. If I have 3 numbers, this is really cool. Listen up. Yeah, we trust you, Jeff. You like really normal stuff. Shut up. If I had 3 numbers and I know that they average to be 10, so I have 3 numbers and they average to be 10. Do you know anything about the 3 numbers? A possible answer is no. Okay, there's somebody says no. You do know one thing. How do you calculate the average of 3 numbers? What do? You add them up and divide by 3. So if the average is 10, what do the numbers add up to be? 30. Right? What do you divide by 3 to get 10? 30. So whatever the hell the numbers are, they have to add to be 30. That is a lot of information. So it could be 10, 10, 10. It could be 8, 10, 12. Right? It could be an infinite number of things. But how much freedom? If I just start making shit up, somebody give me a number. Oh, that's weird. All right. Oh, wait. No, it's 8 and 6. I couldn't see it. I thought 2 people said the same thing. All right, let's put 8 and 6. Right? Can the last one be anything it wants to be in order to have an average of 10? Be careful. What did we just say has to be true about the 3 numbers so that they make sure to average to be 10? They have to add to 30. Can the last one be anything it wants to be? No. It specifically has to be what in this case? Not 20. What do I have so far? Not 18. How much do I have so far? 14. How much more to make 30? Yeah, there you go, Mineski, 16. So tell me this. Did I have 3 degrees of freedom here? Did I have freedom to make all the numbers I want? Now, how many degrees of freedom did we have? We only had 2, right? We can make these 2 anything as long as the last one makes it come out to be 30. We could have made this one 18 billion. As long as this one was negative 18 billion and this one would be 30. Hey, that works. You can make anything work as long as the last dude makes it work. You guys? So watch this. What that means then is that the degrees of freedom, affectionately known as DF, is n minus 1. You always have 1 less degree of freedom with any group of numbers, any size group of numbers. So let's look at this chart again. Let me see. Let me create a situation. Let's say I want to be 90% confident. And let's say n is, let's say it's normal, and n is 11. Is everybody with me? I mean, of course you are. Nothing's happened yet. So it tells me it's normal. So is it okay that n is less than 30? Yeah, it's already normal to start with. I don't need n greater than 30. And I want to be 90% confident. Let me make a call back now. Let's see who remembers this. What the hell's alpha? So, yeah. Alpha, that just means the area in the tail or tails. And a confidence interval always makes 2 tails. So what area is in the tails for this? 10%. So now watch. I'm going to bring back the T-score chart. Here we go. You should see it now. Yes. Let me bring this back. Okay. So now watch this. N was 11. So what are the degrees of freedom? Degrees of freedom. What's the degrees of freedom? Okay, Jeff, stop it, dude. That's bad. It's fun, though. What are the degrees of freedom? What are they? What's the formula? N minus 1. N is 11, so the degrees of freedom is 10. So look at the chart. This is so beautiful. You will really appreciate this when we get into the next chapter. Because right now, what do confidence intervals always make? How many tails? 2. 2 tails. So look at the chart. This kind of seems silly right now that they have an area in 1 tail and an area in 2 tails option. In the next chapter, we'll be doing claim proof, not proof, but finding evidence for claims. And a claim could be greater than something. That would be 1 tail. That's later. Don't worry. So my degrees of freedom is 10. See that right there? Degrees of freedom is 10. And my alpha, the area in 2 tails, is 0.10. See that? So go down to 10, and there's my T-score. 1.812. If I was making a 90% confidence interval and was using Z-scores, I would use 1.645. Remember that? Isn't this bigger? Why is it bigger? So it covers our big old butt for not knowing the real standard deviation, right? So this would be when S is the only thing known, sigma unknown. That word says unknown. You can't even really see that too well, but too bad. So let me say this again. This is a big time note to take. Why were t-scores invented? For when we don't know the population standard deviation. That's it. So when do I use a t-score? When it's normally distributed and I do not know the population standard deviation. My hair is really getting crazy. Oh, too bad. So as has been true this whole time, I can't do shit unless I know it's normally distributed. Once I know it's normal, do I use a Z or a T? Well, it depends on which standard deviation we know. If we know the population standard deviation, Z score. If I only know the sample one, T score. That's it. And in fact, I mean, the formulas tell you that fact. I'll bring it up here in a minute. All right, maybe. So here, a little practice for you. Please discover. Oh shit, I didn't even write that down. What do you get for that? 1.812, right? You guys see that? Degrees of freedom was 10, and a 90% confidence means 10% in tails. Now watch this, Livia. No. If you were to break that up, so how much is in one tail then, for example? If there's 10% outside, how much is on that side? Yes, exactly, because it's symmetric. So 5%. And do you see how you're still in the same column if you do 5% in one tail, 10% in two tails? You're still in the same column. It doesn't matter. And again, in the next chapter, we will find problems that are one tail from the beginning. Right now, we just have a process that's always two tails. So for confidence intervals, I only ever look here, to be honest. Do you guys see that would be a 99%? That would be a 98%, 95, 90, 80%. Kabam, bam, bam. Okay, so try this one. Let's say I have a situation where S is the only thing known. We don't know sigma. N is 81, and I want to be 99%. You guys can't see that, can you? Sorry. Let me see. Sigma unknown. N equals 81, and I want to be 99% confident. How's that? Is that better? Still bad? I don't know how to share and do this. Damn it. All right, hold on. All right. So this is the situation I'm in. Is it okay that it doesn't say it's normal? It doesn't say it's normal. Shit. We're screwed. No, we're not screwed. Why? Why is it okay? Yeah, n's greater than 30. I don't have to. So in the problem I just did, I had to say it was normal because n was only 11. If it wasn't normal, we wouldn't be able to do it. All right. So what's the degrees of, I can't say that phrase without doing it in a bad accent. So just deal with it. What's the degrees of freedom? What are they? Should drink some Guinness while I do this. Yes, degrees of freedom is 80 because it's always n minus 1. All right, so let me share my screen again. 99% confident, so what's alpha? .01. All right, let's look at the screen. Scheisse. Come here, mouse. Top. All right. So 0.01 right there, 0.01. So we're in the first column. If I go down to 80, there's my t-score, 2.639. Ah, shit, we're almost out of time. That sucks so much. Damn. Well, one thing, any questions on that? So let's do at least one problem together of an actual confidence interval. So I'm going to stop sharing again. So I went to degrees of freedom of 80. 1% in two tails was the first column. So that's the score I would use, 2.639. So let's do one quick little problem. And then let's do this and then I'll tell you what I'm going to do. So I'm going to write that down. Let me see. What was it again? 2.639? Is that right? Scheisse. If I just paid more, yes, 2.639. So say we take a sample of 81. We don't know sigma, but we find these two things. We find the sample mean is 15 and the sample standard deviation is 3.14. Okay. So they gave me the sample size. We kind of did this part already. Here's what they see. So what's the formula for this problem? That looks exactly the same as the other formula. It's just a T instead of a Z. It's just one less bar for me to draw on that letter. So you do the same thing we did before. You put the mean in there, give or take this many. Standard deviation divided by square root of n, as always. Oh, what was n? Get out of there. 81, right? Yeah. Get out of there. Nah. Oh, man. I'm embracing my oldness. Bah, do what I want. Let's see if I can guess what that's going to be. Why are you doing this, Jeff? I don't know. 0.35. So that'll be 0.7. 0.89. I don't know. I think the error is around 0.89. I could be really. It can't be 0.89. Is it maybe it is 0.89. I don't know anything anymore. What did I do? What did I just do? Forget what I just said. 1/3 point is, yeah, it is. Yeah. You get to see your teacher just going into insanity. Lifetime. All right. I really desperately hope that you guys, number one, are okay with section 8.1 problems, where there was a z-score here and a sigma there. And then you realize this is the same thing. This is exactly the same thing. They got to tell me the same information. I just have to use a different chart to get the number that goes here. Okay, and it's not even that difficult of a chart. What is the S? Oh, yeah, what is S? What's that taking the place of? What's it taking the place of? So remember, this was the formula for section 8.1. So remember, you cannot have notes to use during a test or a quiz or anything, but I will give you the formula. So look at this beautiful thing. When do I use Z? When I know sigma. When must I use T? When I only know S. The formula tells you. Because T-scores were invented for when I only know S. Both of them require a normal distribution. I mean, you still need that bad boy. Paranormal, that would be stats 3, I think. You don't use the paranormal distribution until way later, right? You get your proton packs and your whatever. Okay. So I do the same thing as always. I calculate the error first, right? And my guess was like 0.9, I think 0.89. I want to see how bad that is. Anybody do that yet? Nobody's done that yet. Let's see. Times 3.14 divided by that. Not too far off. 0.92. I said 0.89, I can live with that shit. That's pretty good. So then, I don't see anybody asking any questions. So everybody understands what the hell I'm doing. So if I do this and this, subtract it and add it, I get 14.1 up to 15.9. Technically, you can make it 14 to 16, make them whole numbers, but, you know, just show a little bit. All right, I'm going overtime here. And then the statement we would make is we are, what was this one? I forgot already. We are 99% confident that the interval 14.1 to 15.9 contains the true mean. And I didn't even tell you what these were. So in general, you need units. You would still write the conclusion. The conclusion is written the exact same way. The only difference in section 8.2 is I use the t-score from the t-score chart, not the z-score from the z-score chart. That's the only difference. So if I knew both sigma and S. Oh, what's up? Do you have to be specific about population or sample? Well, so when I say true, I mean population. You're always trying to estimate what the population information is because I know the sample. I know it. I know the sample means a 15. 100% confident that the sample means 15, right? It's just the population mean I'm not so sure about because I didn't look at the whole population. Very often we can't. Too many freaking people. All right, what was I about to say? Shit, I had something going there. Damn. Oh, well, it's too bad for me. I was about to say something and I forgot. All right, well, too bad. So we finished chapter 8. What I'm going to do, let me share my screen again real quick. I'm going to put, shoot, where are you? Here, all right. I'm going to put this up on Canvas. This is the T-score practice sheet, right? Don't worry about this side down here. Don't worry about this side here. I'm gonna, will I? Sure. I'm gonna make a video for this sheet, all right? So that next time we can try out this side. In fact, I really kind of want you guys to do this side, but we haven't had enough practice yet. Scheiße. So try this out if you want to. I'm going to put the video up about this and then try to get into section 8.2 homework. Okay. All right. Any questions about that stuff? By the way, I was thinking probably a week from today. Should it be a week from today? I'd rather it be a week from today, but let me see. Maybe how about on Wednesday of next week, we'll have a chapter 8 quiz. It'll be that part of what the test would have been that would have covered chapter 8. And then on the 29th, we'll have a chapter 9 quiz. Yeah. That's the current plan right now. So a chapter 8 quiz on the 22nd and a chapter 9 quiz on the 29th. Yay. All right. Any questions? Anybody have any questions? I have a 9 o'clock meeting. Will you give out the quiz practice? No. I don't know. That's a good point, Sir Karn. I think I have a practice test 2 that I will make the solutions for and put them up. I'll try to identify the parts that will be on next Wednesday's quiz and then the parts that will be on the following Wednesday's quiz. So the next practice test would have been chapter 8 and chapter 9. In fact, can somebody right now email me? I need to put a note somewhere and just say, don't forget to do the practice test 2 answer key if you want it to happen. Okay. Let me think. Oh, thank you. What else? Anything else? Any other questions or concerns? I'm gonna have to try to cut my own hair, I think. I look a little bit like Wolverine. Oh, shit. I don't know, Professor X. All right, stop. All right, that's enough. All right, guys. Thank you for coming. And I need to remember two things. Zirkarn, in that email, can you say the practice test answer key and the video on the T-score practice? I know that's asking a lot of you. I'm sorry, but just help me keep track of everything because I have an insane amount of stuff going on. Okay. All right, guys. Thank you. Thank you. Nobody needs to stay after a bit. Everybody's good. Thank God. I got a 9 o'clock meeting I gotta get ready for. All right, guys. I'll see you next time. Go back to bed.